Greetings and welcome to 3dmotive.com. My name is Alan Thorne and I'll be your instructor on this comprehensive course introducing you to the Unity 5 game engine and its exciting feature set. In this module, we'll enter the world of particle systems and image effects. If you want to create rain, smoke, water, flocks of birds, or magical sparkles, then particle systems are just what you need. Here we'll see how to create and configure particle systems inside Unity using the Shuriken system. We'll explore how to read, understand and use its graph-based interface to create real-world particle systems that'll make your games come to life. And then we'll move on to examine additional image effects that can be applied to game cameras to enhance the look and feel of your games, including effects like bloom, blur, screen space ambient occlusion and chromatic aberration. Using a combination of particle systems and image effects, there is practically no limit to the stylizations and flavors you can give to your games. So let's jump in and get started. So in this section of the course, we're going to be dealing with particle systems. And particle systems are used primarily whenever you need to create an effect in which you have many moving pieces working together in the same system. This includes rain, snow, fog, explosions, magical sparkles, energy fields, laser beams, and all kinds of other effects like that in which you have intangible pieces. However, as we'll see, there are also other practical applications for particle systems too. It's possible to put them to more unconventional uses to create effects that perhaps typically we wouldn't think of in terms of particle systems. So we'll see some examples of that as well. Now, to get started at using particle systems in Unity, we don't in fact have to import any kind of asset packages. We can simply choose Game Object and then choose Particle System. However, what I'm going to do here is I'm going to import an asset package simply because it gives us extra graphics and assets to work with. The package I'm going to import is the Particle System package, and you can import that into Unity by choosing Assets, Import Package, and Particle Systems. So I'm going to select that from the menu. Unity will go ahead and ask me if that is indeed what I want to import. I'm going to leave all these options checked at their defaults, and then I'm going to choose Import to import that particle system package. After the import process has completed, we will in fact get two folders that you can see down here in the project panel, the editor folder and the standard assets folder. We can get access to the assets that we've imported through the standard assets folder, and then we get a range of things that we can select here. I'm going to double click on the particle systems folder, and inside this folder we get some textures, shaders, and prefabs and materials. Right now I'm just going to open up the prefabs folder because this comes with a whole range of particle systems that we can simply drag and drop into the scene. These are commonly used particle effects. So what I'm going to do next is I'm going to be taking a look at each of these, or most of these, in turn to see what kinds of effects we can create using these imported particle systems. So the first particle system that I want to consider here is the Steam particle system. You can find that here in the particle systems prefabs folder, and here we have the Steam system. So I'm going to drag and drop that into the scene and release my mouse. And when the particle system is selected, as I have it selected here, and you can see in the hierarchy panel that it is selected, we have this particle effect dialog appear, and the particle system will be playing automatically in the scene viewport. If the particle system is deselected, so if I click over here for example, the entire particle system is put on pause. This of course has no connection to how the particle system will actually play when running in-game. This is simply just a feature in the scene editing mode, just here in the scene viewport, that when a particle system is deselected, it is put on pause. But if I select the particle system again, then it begins to play back. Now here on the right hand side in the Object Inspector, we have all of the features that are part of the Shuriken editor, and we're going to be going into quite some detail over these options throughout this course. But right now I'm just going to leave these features just as they are, and we can see that in the scene we have a single particle system, and that is emitting steam particles to create this steam effect. Now, of course, I can actually still move this particle system, and when I do, you can see how that steam just kind of follows where the particle system is being moved to, and it's kind of nice like that. So again, you're having this particle system, and it's aware of where it is moving in the scene. So that's pretty good. And we have two real components of the particle system. We have the emitter, which is this imaginary point in space here marked by this game object pivot point. And this emitter is effectively spitting or spewing or generating particles into the scene, which is causing this steam effect. So we're going to be seeing more of that later. But right now I'm just going to delete the steam particle system. A similar particle system is the smoke one. I'm just going to drag and drop the smoke one into the scene and release my mouse. And when I do that, we get this smoke effect here. And just as before, I can move this particle system, and the particle system kind of updates with the position where I'm moving it about in the scene. You can see those particles are now generating from that new point as I move it. So here we've seen two examples of particle systems, smoke and steam, but I want to move on and consider some of the other particle systems. In this movie, I want to consider two additional particle systems that are part of the particle system package that we've imported. These two are the flare particle system and the afterburner particle system. Let's start with the flare particle system. So I'm going to drag and drop that into the scene and just frame this in the viewport here. And so what you can see here is we have this particle system that represents a flare. We have this kind of hot, really heated core with sparks spewing out and also some smoke as well. Now, one thing that is important to note with this particle system is that although it appears to us as one single unified effect, what is going on here is actually more complex. And we can see that by taking a look at the particle system in the hierarchy panel. You will see that we have this flare object here, but next to the flare name is this twirly icon that I can click on to expand. And what you actually see is that this effect is simply a collection of multiple particle systems working together. So if I select the flare object here, you can see in the object inspector that it has a particle system component. But if I select the smoke object, that also has a particle system component. And if I select the sparks object, that also has a particle system component. So what I can do, for example, is select the sparks, and if I deactivate that game object up here in the object inspector, we now have the effect but without the sparks. We've deactivated that particle system. The same thing here goes for the smoke. I can select the smoke and deactivate that one as well, and now all we have is this heated core of the particle system. So what we have here is really three particle systems working together. I'm just going to reactivate those separate objects here to create the particle system effect again. So there we have an example of multiple particle systems working together for just one effect. So I'm just going to select the flare system and delete that by pressing the delete key on the keyboard. Now the next particle system that I want to cover is the afterburner system. So I'm going to drag and drop the afterburner into the scene, and straight away we get this particle system. And just as we found with the flare particle system, the afterburner is a complex one, meaning that it has several parts. If I expand the afterburner, you can see we have in fact two systems working together, the afterburner particle system and the glow system. The afterburner effect is particularly useful for attaching to the rear end of a spaceship for a space shooter game, for example. So you can see the kind of effect this particle system is having. One feature that is common to all particle systems is the simulation space. If I, for example, put in the steam particle system that we have seen before, and I move this object around in the scene, you will see that the particles seem to kind of update and know that the particle system is moving. They follow the particle system, but they still seem to be affected by the world space here. If I delete this particle system and again select the afterburner system and I move this around, you see that the effect here, this afterburner effect, it doesn't really follow the object. It simply slides with it while maintaining its position just as it did before. That's because these two particle systems are using two different simulation spaces. If I move over here to the particle system component in the Object Inspector and I slide down, you will see that one of the settings we have is simulation space. The simulation space for this particle system is defined as local. We also have an option to make it world. So when I move this particle system, this is what it looks like in local space. If I now set this to world space, and I also select the glow effect and I set that to world space as well, if I then select the afterburner and move it, you can now see the effect that has when I move the particle system. It seems to update and follow the position of the particle system as it moves through the world. So that's a really important feature of all particle systems, the simulation space. And there are different reasons why you might use these. The world space is useful when you want a particle system to move around in the world and it to appear to be affected by the usual world forces. If, however, you have a different particle system that really must just stay in place, then you will want to use local space. The decision is entirely dependent on the kind of effect that you want to create. So now, let's move on. So from this movie going forwards, what I'm going to be doing now is creating a completely new particle system from scratch, every step of the way, step by step. I'm going to begin with a completely new scene, and the particle system that we're going to end up with is the one that you see in front of you here in the viewport, which can be used for a variety of different effects. For example, it's a kind of firefly effect. We could tweak it a little bit to create a firefly effect or a dust particle effect. We have some kind of ethereal, spacey effect going on where you can see we have these different glowing particles moving throughout the level, kind of changing size, and they're all following a different velocity. And this is simply just one particle system at work here. So this is the one that we're going to be creating. And to get started, I'm going to create a completely new scene. So I'm going to choose File and New Scene, or press Ctrl-N on the keyboard. So here we have a completely new and empty scene with the exception of the camera and the directional light. Now I want this scene to be nighttime, not daytime. So to do that, I'm just going to double click on the directional light that we can see here, switch to the rotate tool by pressing E on the keyboard, and I'm just going to rotate the light to maybe something kind of like this there, where we have still a little bit of a horizon line, but still the rest of the particle system, the rest of the scene rather, is completely dark and nighttime. And this will give us a great beginning to preview our particle system. The next thing that I'm going to do is to create a completely new particle system. To do that, I'm going to move up here to the File menu and choose Game Object, Particle System. So I'm going to select Particle System and press F on the keyboard to frame the new particle system. So here is the completely new particle system, and this is what your particle system should look like when you create a new one. It is the default particle system that's just generating particles into the scene. So this is a good beginning, but of course we've still got quite a way to go. And next up, we're going to be refining this particle system further to create the effects that we need. Next, I'm going to be changing the shape and the emission properties for the particle system using the Shuriken editor. So what I'm going to do is I'm going to select this particle system, make sure it is selected here in the hierarchy panel. And then when you move over here to the Object Inspector and you scroll down, you will see that we have two settings here, emission and shape. Both of these are enabled, which means that the properties that are set for these settings are taking effect in the particle system that we see here. Now you can click on the grey headings here to expand them and reveal more properties. So right now, by expanding the shape property, this gives us access to the shape of the particle emitter. That is the thing which is actually generating particles in the level. So for example, what we have here, you can see, is we have this emitter, which is a kind of cone shape. Now, right now, with the particle system being selected, you can see that I also have the rotate tool active, and I can see the rotate gizmo here in the viewport. I don't really want to see that, so I'm just going to hide that by pressing the Q key on the keyboard to switch to the selection tool. That will just deactivate the rotation gizmo so that I can see the particle system and its properties a bit better. So here you can see the shape of the emitter, which is a cone shape. And we can see that here under the shape panel, the shape is effectively a cone. And we also have this emit from setting. Right now it's set to base, which means that the particles that are generated at the base of the emitter, which is this point here. I can of course change that, for example, to, let's say, volume shell, which means that the particles will be generated around the edges here, along the shell of the model. I can change it also to just volume. The particles will be generated anywhere within this volume. And again, I can change this to base shell. The particles will only be generated around the circular edge of the base here. But I'm just going to switch this back to base. And the particles are now generated within that cone volume. I can also change the angle of the cone to widen it or narrow it, effectively concentrating the particles in a particular area. I can also change the radius, that's the radius of the whole cone, including the base and the top. But more importantly, I can change the shape. For example, I can change it to a box shape here, and straight away you can see the emitter becomes a box, and it produces a kind of different effect for the generation of the particles. Now, based on the system that we want to create, in which particles are going to be traveling pretty much in any possible direction, I'm going to change the shape of the emitter. I'm going to switch this from box to sphere, like so. And notice that when I do that now, we're getting particles that are spewing everywhere throughout the scene. I'm just going to change the radius of the emitter to maybe something like 2.5. I'm just going to type in actually a value of 2.5 to set that there for the emitter, like so. So I think that's a pretty good beginning. The rate, I'm going to change the emission rate. So over here on the emission section, this is the amount of particles that are generated over time. So what we can see here is by increasing this rate, I could really raise this up to something quite high. And when I do that, we're generating a lot of particles very quickly from that emitter, and we're achieving this kind of effect. But I don't want to generate anywhere near this number of particles. I think I'm going to set this to something like 18, and you can see here now the particles are being generated inside that radius, and they're spewing out into this system. So that's a good beginning. It's time to move on. Next, we're going to refine the particle system even further by tweaking some of its main properties. And by main properties, I mean these particle system properties that appear in the Shuriken editor at the top of the particle system. So from the title particle system downwards until where it says emission. So these properties here. Now I'm going to be tweaking these. These effectively define the overall values for the particle system. So for example, I can remove a tick from looping to disable the loopable behavior of the particle system. I also have this play on awake, and when that's enabled, that means that the particle system will play automatically when the level begins. We also have max particles, which effectively caps the entire number of particles that may be available in the system at any one time. So if this particle system happens to generate an excess of particles in excess of 1,000 at the moment, then no new particles will be generated until that limit is reduced, until the number of particles in the system reduces. So this particle system will not allow more than 1,000 particles to be generated in the system at any one time. I'm perfectly happy with how that setting is for the moment. We also have start lifetime, and this determines how long in terms of seconds a particle will live for after it has been generated in the scene. So for example, if I just zoom out a little bit, you can see that the particles are being generated from the emitter. They are moving out into the world, and when they get to around about here, they are terminating, they are dying, and this is controlled by the lifetime. So for example, if I increase the lifetime, the particles will be able to travel for a longer distance because they will be living for longer. And if I reduce this to, for example, 0, then we're going to be left with this kind of thing here where the particles hardly get to live at all. I'm going to reset that start lifetime back to 5 so that we get something like this. I can also change the start color of the particles. Right now they are generated as white, but I could of course change them to any color that I wanted. But right now I'm just going to completely just stick with white. So I'm going to put that back to white. And also we have a gravity modifier, meaning that if I wanted these particles to be affected by the force of gravity, I can increase this value. And notice that when I do that, as the particles are being generated, they are being pulled downwards by the effects of gravity. So you can kind of see how they're being generated from the emitter and then they are falling downwards into the scene. But I don't want that either, so I'm going to change that back to 0. Two settings that I do want to change in particular are the start size, that's one setting, and also the start speed. So right now the particles are all generated at a start size of 1. I can of course increase this to make the particles larger, or I can reduce it to make them smaller. But in fact what I want to do is I want the particles to be generated between a minimum and maximum, so that when a particle is born, its size is ultimately selected at random between a minimum and a maximum value. To do that, I'm going to move over here to the downwards pointing arrow next to start size. I'm going to click in that and a context menu appears. This will appear out of the recording window, but you will get several options that are constant, curve, random between two constants, and random between two curves. I'm going to select random between two constants. So that random between two constants, we get this. The left value is the minimum size and the right value is the maximum size. And now the particles will be generated between these two sizes. But I'm going to change these values to 0.09 and 0.43. And when I do that, the particles will be generated between these minimum and maximum values. So that's one thing that I want to do for my particle system. That will allow us to create some randomization between the particles. I also want to change the start speed. And actually, I'm going to be setting that completely to 0. And when I set it to 0, we get this. And the reason I want to set the start speed to 0 is because soon I'm going to be manually controlling the velocity and the general trajectory of the particles using a further setting down here in the Shuriken editor. So by applying these main properties, we've created a good beginning for our particle system, but there's still quite a bit more work to do, and we'll be dealing with that next. Now I want to give the particles a trajectory. Right now they are generated in the emitter, but because their speed is 0, they don't actually travel anywhere at all. But I want to have more control over the velocity of the particles because I want different particles to travel in different trajectories. So I'm going to scroll down here to the section where it says velocity over lifetime. I'm going to put a tick in that section here and expand this panel. Now by default it gives you the X, Y and Z values that allow you to set the trajectory of the particles. For example, I could increase the Y value, and when I do that you can see that now I'm beginning to move all the particles along that trajectory vector, and they're moving in the local Y axis. I could set that to 0, and I could increase, for example, the Z value, and that will produce something like that. If I wanted them to move in the other direction, I could negate those values, giving them a negative value to move them in the opposite direction. And a similar kind of thing applies to the x-axis, like so. But the problem with setting the values in this way is that all of the particles will be traveling in the same direction, and that is not what I want. So I'm just going to shrink the window here to get access to the context menu. what you can do is click on this downwards pointing arrow, and when you do that you get a context menu. You can choose constant, or you could choose curve, random between two constants, or random between two curves. For example, if I select curve, I can then have access to the x, y and the z values of the trajectory. For example, if I just want to control the x value here, I get access to this graph. So here on the horizontal axis we have the lifetime of the particle. This is where the particle is born, and this is where the particle dies. So currently, throughout the particle lifetime, its trajectory is 0. But of course I could double click on this line to add a new point and increase it so that at the point where the particle dies, they are all again traveling in this direction. But notice the problem with this curve again is that pretty much all the particles are traveling in the same direction, and I don't want that. So I'm just going to delete those changes by pressing the delete key on the keyboard. I in fact want to choose random between two curves. This will allow me to draw out two curves in this graph, and Shuriken will pick randoms between the two extremes for each of the different particles, allowing them to have different directions. So I'm going to choose random between two curves, and I'm just going to expand the Unity editor back here to fill the recording window. So here in this graph editor, I have access to the three axes, X, Y, and Z. I'm going to deactivate these two just so that I can see one at a time. This is the X axis, and right now it's 0 throughout the particle lifetime. But what I can do is I can click and drag, and suddenly what I get is these two curves. So now you can see they're beginning to move in different directions because Shuriken's selecting a random between them. But what I can do is I can double click to add points to the curve. So I'm going to double click here, and I'm just going to pull that down to create some curvature here, like so. And in fact I'm going to cross these two curves to create some extra randomization. And we're getting the particles traveling in these different axes here, like so. Maybe I could just change this curve a bit more, something kind of like this. And then I'm going to change to the y-axis and pretty much do the same for this axis here. So let's just drag these out, double click to add some points. I'm not even being terribly precise about where I'm putting these points. So again, I'm just going to drag this over here, create some extra randomization here on these curves. So something like that. You can see now the particles are beginning to travel in different trajectories. I'm going to do the same thing for the z-axis. I'm going to click on the Y to deactivate that, click on the z-axis to display that axis, and again do the same here. Just double click to add some extra points to this curve. So I'm just going to drag that into here, maybe drag this over here, drag this up here, and straight away you can see the effect that that's having now, and these particles are now traveling in completely different trajectories, and things are looking much better. In this movie I want to refine the appearance of the particles in our system. Right now the particles are using the default particle material, and I want to change that and improve their appearance generally. So we can control the default appearance or the general appearance of all the particles in the system by scrolling down to the bottom of the Shuriken editor, down here to the Renderer tab. I'm just going to click on that tab to expand it, and using these parameters we can completely control how the particles appear. By default, all particles in a particle system have the render mode of billboard. That simply means that what the particle system does is really just generate quad meshes into the scene, and then it applies a particular material to the quad mesh. And in this case it's applying the default particle material, and we can see that here under the material property. I can of course change the render mode if I wanted to. For example, I could choose stretched billboard, and we get particles that look like this. Again, I could change it to horizontal billboard and get particles that are aligned horizontally. I could change this to vertical billboard and get pretty much the same kind of effect that we had originally. And finally, I can have a particle system generate meshes. So for example, if I select mesh, all of a sudden the particle material is applied to cube meshes that are being generated in the scene. Once I select the mesh render mode, underneath it you get the mesh value. And right now we're using a cube mesh for the particles. I can actually click on this and change the mesh that I want to use. So for example, I could select a capsule mesh and we get this kind of effect. I could select a sphere mesh and we get this effect. I could select a cylinder and we get this. I could select planes and we get this kind of supernatural looking effect. I kind of like that, but that's not the effect that we're going for here. So I'm just going to completely change the render mode from mesh and return it back to billboard, because that's the mode I'm going to be using for this particle system. Now I want to change the material. Right now it's set to default particle, and the particle systems package that I imported into the project contains a different material that I want to use. We can access this by opening the standard assets folder, going into the particle systems folder, double clicking on the materials folder, and it gives us a range of pre-made materials for the particle system. For example, if I select this particle, this effect here, you can see the effect that this has. Notice the shader type that it's using, which is particles additive. That means that this particle is going to blend with the background behind it. Again, we also have a particle additive. And again, this one has particle additive, but for the mobile platform. So we have a range of different particle material types. Most of them are additive. Some of them are alpha blend, or this is vertex lit blended. But the particle that I want to use is this default particle. Well, it's not the default particle. Actually, it's the afterburner particle, but it's using the additive blend mode. So I'm going to select the particle system and return back down to the renderer section and just simply drag and drop the material into the material slot. And when I do that, we get much more prominent kind of particles in our system here, and I'm liking how that's beginning to look. The next thing that I recommend you do, in cases where you don't need your particles to cast or receive shadows, I recommend that you always deactivate the shadow casting and receiving settings. In this particle system, I don't need the particles to cast or receive shadows, so for the cast shadows option, I'm going to set that to off, and for receive shadows, I'm also going to deactivate that. And generally, this is the setup that I'm going to be using for the particle renderer part, and that's looking pretty good. Now it's time to move on. I now want to add the finishing touches to our particle system by changing some properties about the color and general appearance of the particles. One thing that I am not very happy with this particle system as it is right now is that when the particles are generated, or when the particles are born, and when the particles die, they completely pop out of existence. So for example, if I scroll in here, you can see that when new particles begin, they just suddenly pop into existence. They come out of nowhere. And when they die, they suddenly just disappear from existence and disappear directly into nowhere. It's an immediate transition between particle off and particle on. Instead, I want the particles to fade into existence, and when they die, I want them to fade out. So I'm going to control that now by moving over here to the Shuriken editor and scrolling down to where it says color over lifetime. I'm going to put a tick in that option and then expand the settings so that I can see what's going on here. Notice we've got a color option and this color swatch dialog. I'm just going to click on that here, and when I click on that color swatch, we get the gradient editor appear. Now we can see that we have this long gradient bar here, and the bottom axis represents the color of the particle over time. The left-hand side is particle birth, and the right-hand side is particle death. At the top here, we have the alpha of the particle. The alpha represents the transparency of the particle. So this is the key here, because this is going to allow us to fade in and fade out the particles by animating their alpha. So I'm going to select the top bookmark here, which is this bookmark. And when I click on that and select it, you can see that we get the value of this slider at this point. So the value of this mark here has an alpha value of 255, which means fully opaque. If I scroll down that slider to 0, you can see what is happening here. The particles begin completely transparent and they fade into fully visible or fully opaque at the point when they die. If I select the end mark here and I also make that 0, the particles will never be visible because throughout their lifetime their alpha is always 0. So I want the particles to begin with an alpha of 0 and to die with an alpha of 0, but of course at some point between I want them to become visible. So I'm just going to click once up here on the top slider, so at this point here, and I'm also going to click again and drag to make the slider at that point there. So for this slider here, I want them to fade into existence, and I'm going to click on that slider here, and at this point their alpha will be fully opaque and then fade out to transparent. So that now what we're getting, if we look inside this particle system, we're getting particles that fade into existence and then particles that just gradually fade out. And that's the look I'm going for now. It's not such a harsh transition between being alive and being dead. No, there's a fade in and fade out effect. Also, I want to change the color of the particles. For the most part, I want them to be completely white, but perhaps somewhere in the middle of their lifetime, I want them to change color. So I'm just going to go down to the bottom axis here. If I click on the left slider, again, you'll see that the color is white. And if I click on the end slider at particle death, the color of the particles there is white as well. But if I click in the center to insert a new slider, I can then click on the color swatch and pick the color. So maybe I'm going to go for something a bit purpley, like so. And now you can see the kind of effect that is having on the particles based on this gradient editor. So I'm kind of liking how that looks here. And in fact, I can switch to the game tab and see how that looks to the game camera. And I think things are looking pretty good for our particle system. We've got particles that float around on their own trajectory. We've got particles that change color. They fade in, they fade out, and things are looking really, really good. So that's the basics of how to use the Unity Shuriken editor. It's now time to move on and have a look at image effects in Unity. In this movie, I want to consider image effects in Unity 5. And what I have open here in front of me is an image effects Unity project that you can find in the course companion files. Basically, what I have created here is a simple terrain scene, and inside the scene I have positioned a third-person controller along with a multi-purpose camera rig, and all this really does when I press the play button on the toolbar is allows me to run the character around the environment. I'm simply using this scene to demonstrate many of the image effects that come with Unity 5. Now, in short, what an image effect is it's simply a component that we can add to the camera in the scene, and it gives that component the opportunity to take the pixels that are produced from the camera, and it can manipulate the pixels before they are actually shown on screen. This gives the image effect the opportunity to change the pixels and effectively apply some effects to the render from the camera. The effects that we are going to consider will vary widely. Not all of them will necessarily be appropriate to the particular scene that I am using. I am merely trying to demonstrate to you the different image effects available that you can use for your own projects. Now, before getting started at using image effects, we need to import the Unity Image Effects package. To do that, we have to choose Assets, Import Package, and then select Effects from the menu. So I'm just going to select Effects. This will then display the Import Package dialog. I'm going to leave all of these settings checked at their defaults and then choose the Import button. When I do that, Unity goes ahead and compiles all of that data and imports the necessary image effects into the project. When the package is imported, the Unity will create two folders. Ultimately, inside the editor folder, we'll find an image effects folder, And inside the standard assets folder, we will also find an effects folder, and these are all responsible for producing the image effects. However, to access the image effects, we won't be using the project panel at all. All we have to do is select the camera in the scene. In my case, because I've added a multi-purpose camera rig, the camera is accessible within that. Here is the main camera. So I'm going to select the camera here. And to apply an image effect to this camera, I'm going to make sure that I'm in the Game tab. The reason for that is because when I'm in the Scene tab, I'm not actually getting a view of the scene from the selected camera. I have a kind of director's eye view here. But when I switch to the Game tab, it's now showing me the scene as visible from the camera, so that when I apply image effects to the camera, they will be visible in this scene in the game viewport as well. So I'm going to make sure the camera's selected and that I'm in the game viewport. And to add an image effect to the camera, all I have to do is move over here to the component menu and choose Component, Image Effects. And keep in mind, this option will only be here after importing the image effects package. And then we have a variety of different effects available to us that give us control over how the scene can look. For example, we have noise effects here. We have blur effects here. Here we have other effects. Here we have bloom and glow effects. Here we have edge detection effects and some additional effects that we can use. But for now, I'm just going to use a color adjustment effect. In particular, I'm just going to really transform the game view into, let's say, grayscale. So I'm just going to select the grayscale effect. And notice that this adds a grayscale component to the camera. So you can see that here. And in the game viewport, you can see that now the viewport has been transformed into grayscale. I can, of course, take the tick out of the effect to restore the color back, or I can just re-enable the grayscale effect and I get grayscale. This effect also holds while during gameplay. So if I press play on the toolbar, and suddenly our game is now grayscale. So that's basically how we can import the image effects package and apply a pretty simple grayscale effect. But there are a lot more effects to consider, and I'll be going over some of those next. Here I want to consider blurring, vignetting, and chromatic aberration, which are image effects in Unity 5. I'm going to select the main camera and make sure that I'm in the Game tab here. And the first effect that I want to add is a blurring effect. So the way I can do that is choose Component, Image Effects. I'm going to go down to Camera and choose Camera Motion Blur. So this is a blurring effect that is not based on the motion of objects in the scene, but is based on the motion of the camera as it moves through the scene. So I'm going to select Camera Motion Blur. So this means that even if the camera were still and objects moved, there would be no blurring. But if objects remain still and the camera moved, then there would be blurring. So I'm going to press play on the toolbar here. I'm going to leave the settings at default and start to move the camera around. And although there is a blurring effect, it is pretty subtle. The camera's moving, and although it's moving, I really can't see the effect too much. So what I can do is I can then just increase some of these values. So for example, velocity scale will increase the strength of the effect as the camera moves. So I'm just going to increase this setting. I'm still in play mode here, notice. I'm going to increase this setting like so. And now as the camera moves, that effect, that blurring effect, is much more pronounced here. So I can see it much more visibly. And that certainly is camera blur there now. I can also use the jitter strength field to increase the roughness of the blurring as the camera moves. And you can see it most prominently on the game character here, that as I'm turning the camera, there's a kind of a noise over him as the camera, a blurring effect is being applied. Now, if I stop playback right now, all of these settings in the camera motion blur will be forgotten and restored back to their original values. But if I am happy with these effects, before stopping playback, I can click on this cog icon and from the context menu choose Copy Component, like so. Now I can stop playback and the values will be forgotten. but I can restore them by clicking on the cog again and choosing Paste Component Values. When I do that, that will paste the values that I used during game mode. So that's one way you can still save the settings of components during game mode, but I'm not going to keep those motion blur settings. I'm just going to click on the cog and remove the motion blur component. By the way, you can also add multiple image effects to a camera to combine them. But the next effect that I want to consider is vignetting and chromatic aberration. So to access that effect, I'm going to come up here to the component menu and choose Component, Image Effects, and under the camera section you'll see vignette and chromatic aberration, and these are two separate effects built into one component. So if I add that, you can see we have some options here. Now, vignetting and the blurred corners refer to one kind of effect, and chromatic aberration refers to a different kind. And I'm going to demonstrate these one at a time. So let's start with aberration. This effect is particularly useful for creating a surreal or dreamy atmosphere, or if your character has ingested some kind of poison or toxin. This is good for changing how the world looks. If I increase the chromatic aberration setting and keep my eye on the game tab, you will begin to see that on the edges here and on the horizon, parts of the world are beginning to change color and pull away. It's also an effect that we can usually animate so that you can create a kind of throbbing or pulsating effect. So I'm going to leave it something like that and press play, and we can see the kind of effect that this gives us really, which is again quite a severe effect that really adjusts the hues and the saturation of the game. So again, this is very useful for a surreal or dreamy atmosphere. So I'm going to stop playback and just reset the settings here. I'm just going to bring in the game window. If you want to reset the values back to their defaults, you can click on the cog icon and then just choose reset. That will reset the settings back to their defaults without having to remove and re-add the component. So I'm just going to stretch the window back here to fill the recording window. We also have vignetting and blurred corners. Now the blurred corners, by increasing this setting, will effectively add additional blur to the edges of the screen. So if I increase the blurred corners value, you can begin to see here already the setting is taking effect. So again, I can increase that blurred corners, and the blur distance just increases the severity of the blur. So you can see what's going on here. If I begin to increase or reduce that setting, I'm just going to remove those back to 0. The blurred corners is especially useful for trying to get the player's attention in a particular area of the screen, particularly somewhere around the center of the screen. Now, vignetting refers to an effect that we can add to the edges of the screen again. This can be useful primarily for attracting attention to the center of the screen again. So if I increase vignetting, you can see that we get a kind of darkness around the edge of the screen that I can intensify to focus attention in a particular area. However, vignetting can also be useful in the negative sense. We can animate vignetting in a negative way, and this can be useful for creating explosion effects. So if I go below 0 and put it to a negative value, you can see the screen beginning to brighten, and now the screen is closing in on the center, and suddenly we just zoom out to this kind of strange effect here. And if we go far enough, the screen is reduced completely to white. So that can be used in the negative sense to create explosion effects. So that's the basics of using vignette and chromatic aberration. Now I want to consider two further image effects, specifically bloom and edge detection. Let's start with bloom. Bloom is a specialization of the blur effect. Instead of blurring things based on their motion or blurring the entire image, it is a selective blur. And what it does is it effectively looks through all the highlights in the image, the brightest points, and then blurs those to create a dreamy feel. It is typically used in fantasy RPG games. So to get started, I'm going to make sure the main camera is selected. I'm going to move to the component menu, choose image effects, and then bloom and glow. There are different bloom effects that we can apply, but I am going to select the bloom optimized effect. So I'm going to select that to add bloom to the camera and scroll down here in the object inspector to see the controls for that effect. Now already in the viewport you can see that the bloom has taken effect. I can enable and disable the component to show you the kind of effect that it is giving us. You'll see that the highlighting it is performing and then the blurring. So we have this threshold slider, and effectively the lower this slider, the more things will be affected by the bloom. So if I raise this slider very high, very little is going to be affected by it. But if I reduce it very, very low indeed, and you'll see that the effect is much more extreme. So I'm going to reduce the slider maybe to kind of about there-ish. And the intensity slider, that basically affects how intense the effect is. I can completely turn it off by setting it to 0. I can really just burn things in the image completely out of any kind of recognition here. But I'm going to put it maybe to about there-ish. And then if I press play on the toolbar, you can see the kind of effect that is having. And we can contrast that with how it would look without the bloom. So if I take the tick off here, you can see the effect that this bloom is having to the image. It gives it a much more dreamy feel here. So I kind of like the bloom effect. I'm going to stop playback here, and I'm going to remove the bloom component. The next effect that I want to consider is edge detection. Now, edge detection is an effect that has many different uses. It is particularly useful if you are trying to create a comic book graphical style, some kind of toon shading, or some kind of very distinctive style in which the edges or the outlines in your level need to be highlighted. So I'm going to select the main camera here in the viewport. I'm going to choose component, image effects, and then edge detection. And here we get two different options, crease shading or edge detection. I'm going to select edge detection to add that component here in the object inspector. And already with the default values set as they are, you can see that it's having an effect. We are getting the horizon line especially being outlined with by black here. Again, we're getting this hillside also being outlined. And if you look carefully, you can see that the outline of the player is also visible. So it's detecting edges or areas of contrast in the image, and it's highlighting those edges. We can use the sample distance setting to effectively increase the thickness of the outline. So when I press play on the toolbar and I play this in the level, you can see that even at runtime it's detecting, even based on the changes in the pixels, where these edges are. So you can see that it's creating these outlines here. Now typically this kind of effect wouldn't necessarily be used to accompany a realist style. It would generally accompany a kind of toon look. And we can also use the mode here, which is currently set to Sobel Depth Thin, and this changes the algorithm or changes the methods that's used for detecting edges in the image. And these will give you quite dramatically different results. I could select triangle depth normals to kind of get this effect, and then I would have to tweak the settings again to really just adjust how these edges are being detected. We have Roberts cross depth normals, we have other kinds of effects, and these really can just radically change the kind of edges that are detected in the image. So that really, in summary, is how edge detection works. Now I want to briefly consider three more effects, specifically screen space ambient occlusion, global fog, and anti-aliasing. These three effects are used widely in games and produce quite different results and are used for different purposes. Let's start with screen space ambient occlusion. What this effect usually does is it analyzes all the components in the image to identify places where objects come into contact with one another, such as where the character meets the floor. At those areas, it tries to add an area of shadow or darkness to simulate contact shadows that we typically find in the real world. So let's add some screen space ambient occlusion. I'm going to select the main camera, choose component, image effects, move down to here to where it says rendering and then choose screen space ambient occlusion. I'm going to select that effect here and it's added here to the object inspector. Now already if we look carefully here in the game tab, by toggling on this effect, you can see here at the base where the character meets the floor, there is a kind of drop shadow around his feet. It's somewhat subtle. I can increase the intensity, making the ambient occlusion slightly more noticeable and slightly darker. We can also reduce the radius setting here to increase the number of things in the image that are affected by the ambient occlusion. I'm just going to increase the blurring just a little bit, like so. And let's just see how that looks. So then I press play on the toolbar and we start playback. I'm getting a bit of corruption here over the character. So to do that, I'm just going to increase the radius to affect slightly fewer things here. And that will slightly to begin to remove that corruption. So you can see here by toggling on the effect on and off the kind of effect that this ambient occlusion is having. So that can be used to add an extra level of realism and is particularly helpful inside indoor environments. So I'm just going to remove the screen space ambient occlusion effect. The next thing I want to consider is anti-aliasing, and this provides a certain degree of polish or smoothness to the renders of our cameras. So right now where you can see the horizon line, we have these hills, and if you look closely there's a kind of jaggedness or roughness to the pixels around the edge, and also there's another roughness around the edge here of the character, and anti-aliasing can be used to just smooth that out. So I'm going to make sure the camera's selected, again, component, image effects, and this time I'm going to move to other and then choose anti-aliasing. And when I select that, you can see the effect that this is having in the viewport. I'm going to toggle it on and then off. And what it does is it adds an extra level of blurring to the image. So the image can sometimes look a little bit more blurry, but it kind of polishes off those edges here, making them smoother. And if I press play on the toolbar, again, we get this extra level of smoothness. So I'm going to just remove anti-aliasing there. And now I very quickly want to show you the fogging component that you can add to the camera. The fog effect effectively desaturates regions of the level that are a long way away or that are in the distance. This helps add extra prominence and life and depth to the scene by drawing attention to objects that are nearer. So again, we choose component, image effects, rendering, and the very top option is global fog. So I'm going to select global fog, and when I do that, if you look carefully at these hills, they are now shrouded in a certain degree of fog. So I can toggle that on and off, and you can see the kind of effect that that is having. And if I press play on the toolbar, you can see that objects in the distance are being affected by that fog. Again, I can toggle this on and off, and it adds a kind of extra depth to the scene and a certain atmosphere and volume. So that concludes really three major image effects: screen space ambient occlusion, anti-aliasing, and global fogging. Now it's time to move on from image effects and particle systems, and what I want to explore here are transparent effects that you can create using materials with the new Unity 5 standard shader. Very commonly when you're creating games, you will want to fade out an object to complete transparency. One common scenario where you will want to do this is if you are using a third-person camera and the player is obscured behind objects in the scene and you want to fade them out so the player can see the character. So what we have here is an object or a scene with some objects, and what I want to do is to fade out this sphere object. Now, by default, this sphere object is assigned the default material, and I'm going to create a completely new material. So down here in the project panel, I'm going to create a new material by right-clicking. From the context menu, I'm going to choose Create and then select Material. I'm going to name this material Matte Trans for transparent, and I can drag and drop that onto the sphere. Initially, nothing appears to have changed, but I can confirm that the assignment has happened by simply selecting the sphere, and in the Mesh Renderer component under Materials, I can see that Matte Trans has been assigned. I'm going to select the transparent material here, and we can see its properties here in the Object Inspector. Now for the albedo color, I'm going to click on that color, and for the alpha component, I'm going to reduce that from 255, which is fully opaque, fully visible that is. I'm going to reduce it down to black, which is completely transparent at 0. But you will notice that the object doesn't fade out at all. There is a reason for that. Let me just reassign this back to fully opaque. The reason is because when using the standard shader, you will see in the rendering mode that by default objects have the rendering mode of opaque, meaning that they will never fade out. But if I click on that drop down, I have several options. In particular, I have the options fade and transparent. And now we're going to explore what the difference between these two is. I'm going to start by selecting fade. And when I click on fade and then I visit the color swatch here and I reduce the alpha, you can see that the object begins to fade out. And at 0, the object is completely invisible. It has been completely faded. And at 1, it's completely visible. So we can fade out this object, and as I fade this out, what you will notice is that the shadow fades with it as well. So this can be used to control the complete transparency of the whole object in the scene. Now if I switch this from fade to transparent, we get a different kind of effect. This time, if I set the transparency to 0, what we are getting here is quite a different effect. The object is being faded out in terms of the albedo color, but we are getting now a kind of glass effect. It still keeps the transparency information. It still keeps all the shininess and the smoothness values. It just fades out the albedo color. So this is especially useful for creating glass effects. So there's the primary difference in the standard shader between the fade mode and the transparent mode by combining that with alpha values. So that completes the image effects section of this course. I hope you found it useful. My name is Alan Thorne and you've been watching 3dmotive.com.